All right, welcome. Sketching and finding coterminal angles. So sketch the angle and find two coterminal angles. If I'm going to sketch this angle 3 pi fourths, the first thing I'm going to do is just draw my axes, and I will draw it for the next angle as well. And I'm going to start with the sketching. Because this is a positive angle, I'm going to be starting on this x-axis in the positive direction, and then on the positive portion of the x-axis. And then because it's a positive angle, I'm going in the positive direction, which means counterclockwise. And what I want to do is go 3/4 of a full pi. Well, pi is right here. So I'm essentially saying I want to cut this into four pieces. 1, 2, 3, 4. And I'm going 3 of them. So that's the angle 3 pi fourths. We can label it right here, 3 pi fourths. What I want to do is find two coterminal angles. So if I take 3 pi fourths, and if I say, well, you know what I could have done is I could have gone in a whole circle, just, gone around a whole circle, and then got an additional 3 pi fourths, I would be right there. So that's going to be 3 pi fourths plus that full circle that I went, which is 2 pi. If I add 3 pi fourths plus 2 pi, keep in mind that if I rewrite 2 pi, that's really 8 fourths. So I get 11 pi fourths. This is a different angle that ends at the same spot. Or what I can do is say, hey, you know what, I'm here at 3 pi fourths. But let's say that I went backwards an entire 2 pi just to get back to that same spot. Well, what have I done? I've started at 3 pi fourths. And now what I've done is I've taken away a whole circle, taken away because I went clockwise. So I'm going to subtract 2 pi. Well, 2 pi again is 8 fourths. So this gives me -5 pi fourths. These three angles have different measures, but they're ending at the same spot. They are coterminal. All right, r equals -4 pi thirds. So the negative direction means I'm going to be starting here and going downward. And 4 pi thirds. So I'm splitting pi into thirds. So this would be 1. This wasn't a very good thirds. Let's move this a little bit. Sorry about that. I'm just going to be really picky. Oh, no, it's not going to let me move it like that. Okay, yeah, there we go. I'm going to move that. Can I move you? No? Okay, whatever. We'll just leave it there. This would be 1, 2, 3. And I need 4, so I'm going to have to go all the way to like here. So I've gone 1/3, 2/3, 3/3, or 1, 4. So this is -4 pi thirds. If I want to find two coterminal angles, all I have to do is add 2 pi and subtract 2 pi. So 2 is the same thing as 6 thirds. So this would give me 2 pi thirds. You'll notice this is the same as if I had just gone +1, +2. They're coterminal. Or -10 pi thirds. So if I had gone -3 thirds, -6 thirds, -9 thirds, a whole nother -1/3 would give me -10 thirds, and I'd be at that same spot. All right, next, complementary angles. So you all have learned about complementary, supplementary angles. You learned them in terms of degrees, and now we just want to be familiar with doing it in radians as well. It's the same mentality. Complementary angles are angles that have a sum of 90 degrees or pi halves radians. Supplementary angles are angles that have a sum of 180 degrees or pi radians. So if I want to find the complement of pi thirds, I'm not going to do like 90 minus pi thirds. What I'm going to do is pi halves, the radian equivalent, minus pi thirds. When I'm subtracting this, I need a common denominator, so I'm just going to crisscross and say, okay, I will multiply by 3 over 3 and 2 over 2. So this is 3 pi sixths minus 2 pi sixths, which gives me pi sixths. So the complement of pi thirds is pi sixths, also meaning if I were to add pi thirds and pi sixths, I'd get pi halves. Finding the supplement of pi fourths. Supplementary means it's going to add up to pi radians. So I'll do pi minus pi fourths. And if you wanted to get a common denominator here, we'd rewrite this as 4 fourths. And our complement then, supplement will be 3 pi fourths. All right, a nice easy type of question. Determine which quadrant each lies in and sketch a graph of each angle. So I'm going to make sort of a giant graph here first. And I will attempt to do each one of these in a new color. So 2.5 radians. When we think about this, here I have pi. Pi is 3.14 radians. Right here, I have pi halves. Half of 3.14 is 1.57. So what do I know about 2.5? Well, it's got to be somewhere here in this second quadrant because it's between 1.57 and 3.14. We may not know exactly where. I'll just put it right here. And I will say that this is 2.5 radians. Next, negative 1.25 radians. So negative, oh, sorry, we forgot something here. We should just say, okay, we went like that. You know, not a big deal, but since we labeled it right here, not a big deal. Negative 1.25 radians. So the negative tells me I'm going to be starting here and going in this direction. This wouldn't be negative 1.57 since I'm going in the negative direction. And negative 1.25 is smaller than that, or larger if you are thinking about the negative, but I'm thinking about the absolute value. So negative 1.25, again, the negative telling me direction, the 1.25 telling me sort of the openness of that angle. This is in the fourth quadrant. 5 pi fourths radians, and I should label this last one. I apologize again. Negative 1.25 rad. 5 pi fourths. So I'm thinking about going in the positive direction. I want to split this into fourths. So here's 1/4, here's 2/4, or half, here's 3/4, here's 4/4, and down here is going to be my positive 5 pi fourths. And I'll loop around and say, hey, here I've got 5 pi fourths, which is in my third quadrant. Next, 5 pi thirds. So it's positive, which means I know I'm going like this. 5 pi thirds, if you think about that, pi would be 3/3. So this right here is 3/3. 4/3 would be something like right here. 5/3 will then be something like right here. 6/3 would be coming back to this. So roughly right here, I have my 5 pi thirds. And I'll draw my angle going around there, just showing sort of that direction. And I'll even be nice enough to fix that. Okay, great. Last, I guess, gray. Negative 5 pi sixths. So it's negative, which means I know I'm going in the negative direction. 5/6 is less than going a full pi. And how much less? Well, it misses it by just a sixth of a semicircle. So it's going to be somewhere around right here. If I draw that line going out that, I'd have this angle, which I call negative 5 pi 6. Sort of a messy graph, but we have things labeled and you don't necessarily need these circles going around. But we're going to use them for a while just to help us show direction. All right, so next we have sort of what we're building to in or towards in section 4.2, degree measures that you need to be familiar with. So starting off, 0 degrees, 30 degrees, which is a 12th of 360, 45 degrees, which is an 1/8 of 360, 60 degrees, which is 1/6 of 360, and 90 degrees, which is a 1/4 of 360. If you notice, this goes 1/4, 6th, 1/8, 12th. So you're always working in even numbers and increasing almost always by 2, except for right here, you'd have a little bit of a jump. These fractional things, not entirely super important, but it would be a good thing to try and get down. The things that you want to try and get down is just where are these degrees and only these degrees. You know, like 110, yeah, cool. Know that it's in this second quadrant, but it's not one of the things that we're going to have to memorize. These are all angles that you are going to have to memorize and also end up memorizing a whole bunch of stuff about them. But the first thing is you're going to have to know the order that these go in and know what those angles are. And you'll notice some patterns like, okay, 0, 180, 90, 270, and 360 should be easy because you know what a 90-degree angle is. This is just another 90. This is another 90 and another 90. And then after that, it's all just sort of multiplication of this first quadrant. So 30, 60, 90, 120, 150, 180, 210. What I'm doing is adding 30 over and over and over again. And same thing with the 45. It would be 45 plus 45 is 90, plus 45 is 135, plus 45 is 180, and just sort of moving through that circle. So then we want to talk about how do we convert degrees from radians and from radians to degrees for those problems that aren't sort of easy, like pi halves we know is 90. So since there are 180 degrees in pi radians, we're going to be able to use this as a conversion factor. So if I want to go from radians, let's switch this color. If I want to go from radians to degrees, I'm going to multiply by 180 over pi. 180 degrees over pi, so that whatever radians I had will end up canceling, and I'm going to be left with degrees. If I want to go the other way and get rid of degrees, I'll have degrees in the denominator, so pi over 180. So if I have 5 pi fourths, and I want to convert to degrees, well, because I want to convert to degrees, I know that degrees needs to be on top, which is 180, and pi needs to be on bottom so that it will end up canceling. When you multiply this, you're able to do one of two things. You could either multiply this first or cross-reduce first. It's totally up to you. If I multiply 5 times 180, I get 900 over 4, which is 225 degrees. 330 degrees, which is not what I wrote, 330 degrees times, I'm trying to get rid of degrees, so I know that that will be on bottom, pi will be on top. In this case, it's not exactly about multiplying, it's simply about cross-reducing. The 0 over 0 will cancel, so I'm left with 33 pi over 18, which reduces further because 3 goes into both of these. So this is 11 pi over 6, or 11 over 6, and you could put the pi at the end. And then last but not least, arc length. So we talked about in the day 1 notes, remember that theta is equal to s over r, which means if I were solving for arc length, but in terms of radians, I would have s is equal to r times theta, and just multiplied by r on both sides. So if I had a question that said, find the length of an arc whose central angle is 3 pi fourths radians and has a radius of 5 inches, I'm finding the length of the arc. So I'm solving for s. I'm given the angle 3 pi fourths and the radius in inches, 5. This gives me s is equal to 15 pi fourths. And this is going to be in terms of inches, which, that, while exact, is not exactly helpful in understanding, well, okay, so how long is that really? How many inches am I going to have to cut? That's approximately 11.781 inches. All right. So that's your day one, day two notes. It's a lot of just familiarity with what these terms and things are. So it's relatively easy homework, but you really need to have down, like, I'm going to say the most important things are going to be like coterminal angles, being able to understand what they are and how to find them, and then memorizing all those degrees. That's really going to be an important thing, is knowing where they fall, what quadrant they fall, and the order in which they go in. All right, bring any questions that you might have.